Good morning, everyone. Today is the first day of our lesson series. So, we are going to cover quadratic equation lesson for the advanced level combined math syllabus, right? And in this series, we are going to cover the theory part and the questions, including past paper questions, right? So, therefore, everyone, those who are sitting for the A-level exam this year and next year can join this class. Right. Then you can cover every aspect of your lesson and you can get high results. Right. So then we can start the lesson. Right. So in this lesson, I'm going to cover these parts. Right. So quadratic equations is the first part I'm going to cover. Quadratic equations and quadratic functions. Right. Quadratic equations and quadratic functions. So first I'm going to cover this part of this lesson. Right. So our main lesson is quadratic equations. Then I'm going to cover in this series basic equations. And next, remainder theorem and factor theorem. Right. Next, we are going to cover analysis of functions. Then we are going to cover partial fractions. Right. So these are the 5 parts that we are going to cover in this series. Right. You know that you have done a little bit of quadratic equations in O-levels too. So you know something about quadratic equations, but we are going to start from the basic part. Then we are going to go deep into this lesson. Right. So everyone who are sitting for the 2024 A-levels and 2023 A-levels, you can refer this lesson. Right. So now we can start the lesson. Right. So let's first consider a polynomial function of degree n. A polynomial function of degree n. Right. Now look at this. Fx equal to a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus up to an. So I will explain what is the meaning of this. So this is the standard notation, standard format of a polynomial function of degree n. So here n is the power of this term. Next term power is n minus 1, n minus 2. So you can see that power of x term will reduce up to 0, from n up to 0. So a naught, a1, a2, a3 and an, these are just constant terms, right? So here n is greater than or equal to 2 and n is a positive integer, right? When n equal to here, so this is the standard format of a polynomial equation. This is a polynomial equation. Polynomial equation is a polynomial function is a function of degree n. right? X to the power n. We start from x to the power n up to x to the power 0. Now when n equal to we will get a polynomial function with degree 2, right? We will get a polynomial function with degree 2. N is the degree, right? N is the degree. Degree means the maximum power of this polynomial function. Degree is the maximum power of the polynomial function. So we have maximum power in this first term. In the second term, the power is less than the first one. In the third one, the power is also less than the first one. So n is the maximum power. So that is the degree of this equation, right? Okay. Then when n equal to 2, we can write down fx equal to a naught, instead of n we have 2, a naught x square plus a1 x to the power 1 plus a2. So here a naught, a1, a2 are just constant terms, right? So so in here also degree means we have said that here degree means the maximum power. So here maximum power is 2, so degree is 2, right? Then this is a quadratic equation. This is a quadratic function. That means we have a power of 2. The maximum power is 2 in here, right? So standard notation for this quadratic function is fx equal to a x square plus dx plus c. This is the standard notation or the standard format of a quadratic equation, right? Fx equal to ax square plus bx plus c. Now we are going to use this standard notation for the next part of this lesson, right? So here a comma b comma c are real numbers. These are real numbers, and simple a is not equal to 0. Simple a is not equal to 0, right? Okay. So so here we use this standard format. After this we use this standard format to simplify the problems in this lesson, right? So an important technique that we are used in this lesson is completing the square method, right? And so we use completing square method to simplify or factorize a quadratic function. So completing the square method, you have done that in O levels too, but we are going to start from the beginning. Therefore, we are going to do the completing square method. Then we can use that for the next problems, right? So there are two basic steps to this completing square method, right? There are two basic steps to this completing the square method, right? Completing the square method for quadratic functions, right? So there are two steps. Step 1, right? There are two steps for this completing this square method, right? Step 1 is the quadratic function. The quadratic function should be in the standard form. Should be in the standard form, right? That is the first step of this completing this square method. We are using this method to simplify the problems in this lesson, right? Step 2, second step, the coefficient the coefficient of the x square term. The coefficient of the x square term should be +1. Right? So first step is quadratic function should be in the standard format. So we know the standard format. Standard format is ax square plus bx plus c. Right? Standard format is this. This is the standard format. Fx equal to ax square plus bx plus c. This is the standard format. So first step is quadratic function should be in the standard format. That means first you have to have x square term, then next x term, then constant. Right? Step 2, the coefficient of x square term should be +1. So here x square term, the coefficient of x square term is 8. You have to make this +1. So these are the two steps we are going to follow when we are doing the question, when we are doing the completing this square method. Right. Next, I'm going to show you an example how to do this. Right. So let's consider y equal to 2x square plus 3x plus 1 equal to fx. Right. Y equal to 2x square plus 3x plus 1 equal to fx. So this is a quadratic function. Here we have x square term, x term, then constant term. So this is in the standard format. Right. This is in the standard format. But if you look at this, the coefficient of x square term is 2, not +1. So we have to change the coefficient to +1. Right? We have to change the coefficient of this to +1. So I'm going to separate 2 from this function. Then we can write down 2 brackets x square plus 3 over 2x plus 1 x. So now here we have +1. If you multiply by 2, you get the same function, right? Then now we can use the completing the square step, right? So look at this. 2 into, we have x square term, x term, and the constant term. Then first we have to take the x square term without the square, right? Take the x square term without the square, then x. If there is a positive, take the positive here, take the plus sign here. If there is a negative sign, take the negative sign here, right? Right. Then divide the coefficient of this x term by 2. Then take it down here. If you divide the coefficient of this x term, it will be 3 over 4. Then take the square of the whole thing. Right? Then minus square of this constant 3 over 4. Square of this constant 3 over 4. That means 9 over 16 plus the remaining part half. Right? So that is the completing the square step. Right? Then we can simplify this and we can factorize the function. Right? So I will explain this again. So here we have x square term, x term, and the constant term. Right? Then we are going to take down the x square term without the square x. Then if there is a plus sign, take the plus sign. If there is a negative sign, take the negative sign here. Then divide the coefficient of x term by 2. Then take it here. Now take the square of the whole thing minus square of this constant 9 over 16 plus the remaining part. Right? Then we can simplify this. Y equal to 2 x plus 3 over 4 square minus 9 over 16. If you multiply numerator and denominator by 8, we will get 8 over 16. Right? Now we can write down y equal to 2 times x plus 3 over 4 square minus 9 plus 8. That means minus 1 over 60. Minus 1 over 60. Right? Now we can use the difference of two squares to simplify this, right? So here we have a complete square, x plus 3 over 4 square, minus we have 1 over 16. So we can write down 1 over 16 as 1 over 4 square, right? We can write down this one, y equal to 2 times x plus 3 over 4 whole thing square minus 1 over 16 we can write down as 1 over 4 square. Now we have difference of two squares. Now we know that a square minus b square equal to a minus b into a plus b. Right? A square minus b square equal to a minus b into a plus b. Here we have a square minus b square. Right? So square, complete square minus another complete square. Now we can factorize this using this method. So y equal to 2 times first factor x plus 3 over 4 minus 1 over 4 into second factor x plus 3 over 4 plus 1 over, right? Here we have a square minus b square. First factor is a minus b, second factor is a plus b. Here x plus 3 over 4 act as simple a, 1 over 4 act as simple b. So a minus b, first factor, a plus b, second factor, right? Now we can simplify this by equal to 2 into, here if you simplify this, x plus 3 over 4 minus 1 over 4, 2 over 4, that means half. Here we have x plus 1. Now we can multiply this factor by 2, then y equal to 2x plus 1 into x plus 2. Right. So in this way we can factorize or simplify a quadratic function. So this is the completing the square method, right? Then let's do another example. Right? I think you have understood this one. We can do another example. Right. So write down y equal to 2x square plus 7x plus 6. Right. So this is in the standard format, but the coefficient of x square term is not plus 1. So here we have this function is in the standard format. We have x square term, x term, and the constant term. But if you consider the coefficient of x square term, it is plus 2, not plus 1. So we have to change that into plus 1. Right. So we can separate 2 from here. Then 2 into brackets x square plus 7 over 2x plus 3. So here we have, now we have plus 1. So if you multiply by 2, we have 2x square plus 7x plus 6 plus 3. Right. Now we can use the completing the square step. Y equal to 2 times. Right. So look at this x square. We can take the square term without the square x. If you have a plus sign, take the plus sign, then take the coefficient of x term and divide it by 2. Then it will become 7 over 4. Right? It will become 7 over 4. Take the square of the whole thing minus the square of this coefficient, constant 7 over 4. So minus the square of this square of 7 over 4 means 49 over 60 plus 3. Right? That is the completing square step. So I will explain again. If you have x square, take the x square term without square. Then take the plus sign. If you have negative sign, take the negative sign. Divide the coefficient of x term by 2. Then take it here. Then take the square of the whole thing minus square of this constant plus the remaining part. Right? Now we can simplify this. Here we have 3 over 1. Then y equal 2 times x plus 7 over 4 square of the whole thing minus 49 over 16. So if you multiply numerator and denominator of this by 16, we have 48 over 16. Then we can write down y equal to 2 into x plus 7 over 4 square minus 1 over 60. Right. So again we have difference of two squares. Here we can write down 1 over 16 as 1 over 4 square. Right. We can write down that as 1 over 4 square. So I'm going to erase this part. Then we can write down y equal to 2 times x plus 7 over 4 square of the whole thing minus 1 over 15. We can write down as 1 over 4 square of the whole thing. Now we have difference of two squares. A square minus b square. So we can write down as a minus b into a plus b. Right. Y equal to 2 times first factor a x plus 7 over 4 minus 1 over 4. Second factor x plus 7 over 4 plus 1 over 4. Right. Plus 1 over 4. Then we can simplify this. Y equal to 2 times. If you simplify this 6 over 4, that means x plus 3 over 2. Second factor x plus 2. 7 plus 1 is 8 divided by 4 is 2. Now we can multiply this factor by 2. Y equal to 2x plus 2 into x plus 2. Right. So this way we can simplify this quadratic equation and separate that into two factors. Right. So that is the completing square method. So this is a simple technique that we use to simplify our problems. Right. Then let's go to the next part. Right. So now let's consider three functions. Right. I will consider three functions. First one, fx equal to x square plus 2x plus 1. This is the first function I will consider. Then next I will consider fx equal to x square plus 2x plus 2. This is the next function. Then I will consider fx equal to x square plus 2x minus 3. Right. So here we have three quadratic functions. First one is x square plus 2x plus 1, x square plus 2x plus 2, and x square plus 2x minus 3. Right. So I am going to simplify these three functions separately by using the completing square method. Right. So look at this. Fx equal to here fx equal to, now we have if you consider this, we have x square term, x term, and constant term. So this is in the standard format, right? But and also here the coefficient of x square term is plus 1. So now we can do the completing square steps at once, right? So take the x square term without the square, so x, and take the coefficient of x term and divide it by 2 plus 1. Take the square of whole thing minus square of this constant minus 1 plus 1. So minus 1 and plus 1 will cancel. Then fx becomes x plus 1 square. Right. it will become x plus 1 square. So this is a complete square, right? This is a complete square. Right? This is a complete square. Right. Same way we can use this method to simplify these two functions. Right. Now fx equal to I will simplify this using the same technique. So here fx equal to, here also we can take the x without x square x plus divide the coefficient by 2 1, take this square minus the square of this constant 1 plus 2. If you simplify fx equal to, fx will become x plus 1 square plus 1, right? So here we have a complete square plus another complete square, that is 1 square, right? 1 square means 1. So here we have two complete squares. Right? We have the sum of two complete squares. Here we have sum of two squares. So we cannot simplify this further, right? Same way, we can simplify this function also, right? Here also we can write down fx equal to. So I'm going to explain about the roots and solutions of this quadratic functions using this. So first I have used the completing square method to simplify these two functions. Here we have a complete square, that means x square 1, x plus 1 and x plus 1. Those are the two factors here, right? Here we don't have any factors. This is the sum of, this is in here we have sum of two squares, and also I'm going to simplify this function. So here if you can get x here, plus divide the coefficient of x by 2 plus 1, take this square, this then minus square of this 1 minus 3, right? Then we can write down fx equal to x plus 1 square minus 4, right? So we can write down this as fx equal to x plus 1 square, 4 means 2 square. Now we have difference of two squares, x plus 1 square minus 2 square, difference of two squares, right? So write down, here we have difference of two squares, right? Now because we have difference of two squares, we can factorize this by so here we can by using the difference of two square formula, right? We know that a square minus b square equal to a minus b into a plus b. Here this one we can consider as simple a, this one consider as simple b. So a minus b first factor, a plus b is the second factor, right? Then write down the two factors. Fx equal to first factor x plus 1 minus 2, second factor x plus 1 plus 2. Then fx equal to x minus 1, x plus 3. So these are the two factors, right? So here we have two factors, x minus 1 and x plus 3. Here we don't have any factors. Here we have equal two factors, x plus 1 into x plus 1. Right? Here we have equal factors. Fx equal to x plus 1 into x plus 1. Two equal factors. Here we have two different factors. Here we don't have any factors. Right? So write down here. Now I am going to draw the function of these three quadratic functions separately. Then we can analyze these three functions, right? Then we can find the solutions of these three, right? So before that, write down here. This one has two equal factors, right? Write down. In the first one has two equal factors, right? Next, in here, write down right in here. Cannot factorize for right in here. Cannot factorize further. Cannot factorize further. Here, write down. Can be separated into two different factors. Can be separate into two different factors, right? Okay. Now I'm going to draw the graphs of these three functions, right?